so the last lesson in Unit 2, and that is Module 1.8. And this one is solve rate problems. And I'm going to go old school today with all my questions written out over here. My smart board is not working this morning, but of course. All right. So Unit 2, Module 1.8. Learning target, I can solve real-world problems involving rates and unit rates by using bar diagrams, double number lines, and equivalent rates. The vocabulary is rate and unit rate. You also want to check my other video that I've created on rates and unit rates for more questions and different methods of solving this, okay? So let's start with the first problem, and it says that Destiny drove 225 miles in 4 hours. Santiago drove 248 miles in 4 hours. At these rates, how many more miles can Santiago drive in 9 hours than Destiny? All right, so if you look at this one, we are first going to do this by creating a bar diagram to represent the rates, okay? So I'm going to draw two bar diagrams, okay? One is for Destiny, and the other one is for Santiago, okay? Santiago. So, two diagrams, and we're talking about 4 hours. So, this is 1, 2, 3, 4. Same thing. 1, 2, 3, 4. Okay, Destiny drove, this is supposed to be 220, not 225, sorry. Okay, this is 220 miles. Okay, so Destiny drove 220 miles. So this much is 220 miles, okay? And Santiago drove 248 miles. 248 miles, which is this much. All right, so now we can see that we are going to find the unit rate. So you can divide the total number of miles each person drove by the number of sections in the diagram to find the unit rate. And then the number of miles they drove per hour, that's what it's going to be, okay? So if I divide 220 by 4, that's what this is, okay, 220, and I am dividing this by 4 to get per mile over there. I'm going to get 220 divided by 4 gives me 55, okay? So this is 55, each of these is 55 miles per hour, okay, 55 miles per in 1 hour, okay? So literally, what have I done? I have taken the 220 and I can write it this way, or if I keep it as an equivalent ratio, I'm going to show you as an equivalent ratio also by 4, okay? And so what am I doing? I am saying this is an equivalent ratio, so divided by 4, divided by 4. Okay, and I get 55 miles in 1 hour. All right. Santiago, on the other hand, is 248 miles, and we're talking about miles. Okay, please remember this is miles, and this is 4 hours here. So miles in 4 hours, and so in 1 hour, we are dividing by 4. Same thing here, dividing by 4, and I get 62 miles per hour. So each of this is going to be 62. So I'm just trying to show you the bar diagram as well as the equivalent ratio method. All right. So now that I have this much, we are going to see each hour Santiago can drive, because he has 62 and he has 55, right? So I'm going to do 62 minus 55 because that's how much faster he is going, right? So 7 miles more. So this gives me 7 miles more than destiny. More than destiny. This is in each hour. In each hour. Okay, 7 miles more than destiny. And so this is in 1 hour. Okay, so each hour it's this much. Okay, and so then it's asking how many more miles can Santiago drive in 9 hours than destiny. So if in 1 hour it is 7 miles more, so in 9 hours, it is going to be 7 times 9, which gives me 63 miles more than destiny. Okay, so 63 miles more than destiny. So that's how I can solve this. Now once again, I showed it as a bar diagram and then as an equivalent ratio format, and you can easily solve it like that. All right, so let's do another problem which I have set up over here. So I'm going to go ahead and erase this. Okay. So let's do this other problem. And here we go. I'm going to pull it like this so you can see what I'm doing. All right. So, a warehouse sells 15-ounce cans of tomato sauce by the case. Each case contains 6 cans and sells for a price of $9.96. At a local grocery store, 3 15-ounce cans of the same brand of tomato sauce are on sale for $5.67. A caterer needs to buy 36 cans. How much will the caterer save by buying 36 cans from the warehouse instead of from the grocery store? So we are going to look at this, and I'm going to use this part to write on. Okay. So we're going to construct a bar diagram to represent each situation, okay? And we're going to draw 2 bars. One is going to represent the cost of tomato sauce cans at the warehouse. So we're going to do the warehouse, which is $9.96 for 6 cans, okay? So making a bar diagram for the warehouse, okay? And for 6 cans, 1, 2, 3, 4, 5, 6, it is $9.96. Okay, this is for 6 cans are for $9.96. All right, then I have the grocery store. Okay. So we are looking at the same thing at a local grocery store. 3 of them, because these are both the same amount, which is 15 ounces, but 3 of them cost $5.67. Okay, so this is at the grocery store. At the grocery store, we have 3 of them for $5.67. Okay, so what we're going to do is we are first going to find the unit price. So we are going to divide the total price for each by the number of cans to find the unit price or the price per can. So $9.96, when I divide by 6, I'm going to get $1.66. All right, $1.66 per can. Because look, $9.96. What am I doing? for 6 cans. So for 1 can, how much will it be? Okay, this is for 6 cans. So for 1 can, we are going to get how much? So what do I do here? I divide by 6. Whatever I do to the denominator, I do the same thing to the numerator. I'm dividing by 6 and I get $1.66. Okay, so each of these are $1.66, $1.66, $1.66, all right? Because we're trying to find the unit cost first. In the other one, I have $5.67, okay, $5.67, and this is for 3 cans. So this is going to equal how much? For 1 can, I'm going to have to divide by 3. Same thing here, I divide by 3 and I get $1.89. I get $1.89. So guess what? Each of this is going to be $1.89. $1.89. $1.89. Okay? And that's the unit rate. So the unit price is $1.89 per can here. This is it. And then for this one, it is $1.66 for 1 can. And so the caterer will save how much? The caterer will save $1.89 minus your $1.66. $1.66. Okay, and that gives me 23 cents because 3 and 2, here we go, 23 cents per can by buying from the warehouse instead of the grocery store. So to buy 36 cans, because this is per can, so for 36 cans, we are going to do for 36, we are going to multiply because that is for 1 can. For 1 can, that's how much he's saving. Okay. We'll save this much. And so for 36 cans, we are going to be doing 36 times 23 cents, or here, this is how I write it out. Okay, and I end up with $8.28, and that is my answer. All right, so once again, please convert it to unit rate first, and then you can compare and then see how much the person is going to save overall. All right, so this is how we solve these problems. Let's do another one using a double number line. Okay, I'm going to use a double number line for the next one. Okay, so the question states that a vet is measuring the number of heartbeats of a dog and cat for 4 minutes. Okay, so we have this is, I'm going to write it down over here really quick. And so we have the animal, and we have the heartbeat, and okay, and so the animal, we have the dog, and we have the cat, and heartbeat for the dog is 360 for 4 minutes. For cat, it is 520 for 4 minutes. At these rates, how many more times does the cat's heart beat in 6 minutes than the dog? So this is for how much? This is for 4 minutes. All right, and then it's asking for how much more does the cat's heart beat in 6 minutes than the dog? Okay, how much more? All right, so we're going to use a double number line. So to construct a double number line for 4 minutes, okay, we are going to have heartbeats and we are going to have minutes. Okay, so in 4 minutes, the cat's heart beats how much? So it's going to be, first let me do this. Let me make this double number line. This is one and this is the other one. Okay, and this is heartbeats per minute. Heartbeats per minute. Okay, and the difference in the heartbeats, okay, so we have over here, let's put it as, I'm going to go here, this is 0, 1, 2, 3, 4, 5, and 6. Okay, so because they're talking about the how much more in 6 minutes. All right, so in 4 minutes the cat's heartbeat is how much? 520. Look, minus the 360. Okay, and if I'm doing that, so you get 160 over here. Okay, it's 160 more than the dog's heart. Okay, so cat's is beating 160 more than dog's heart. Okay, more than dog's heart. All right, so once we have looked at this one, we've drawn a double number line to represent the difference, and we are going to use scaling to find the unit rate. Okay, so we said that in 4 minutes it is how much? It is 160. So I'm going to put 160 over here. That's the difference between them. Okay, so difference in heartbeat, we are going to use scaling to find the unit rate. So scale back to find the difference in heartbeats for 1 minute. And then we are going to scale forward to find the difference in heartbeats for 6 minutes. Okay, so if this is 160, all right, and then I am dividing or going backwards. So for if this is, so divided by 4, I get 1. So 160 divided by 4, so I'm just scaling backwards and I get 40, right? And then this is divided by 2 to get this. If I divide 160 by 2, what do I get? I get 80. Okay, and then I can just scale forward and I can just do times 3, because 1 times 3 is 3, and what is 40 times 3 is going to give me 120. All right, so I'm scaling back and forward based on this. And then I can do times 5, and so 40 times 5 gives me 200. And then times 6, so 40 times 6 gives me 240. All right, and so that is why I can see the cat's heart beats 240 more times in 6 minutes than the dog's heart. So this is one way to do it, is just using those number lines. Okay, I can also solve equivalent ratios. All right, and I can say that the difference was in 4 minutes, I had 160, right? That is a difference. So in 6 minutes, how much would this be? So I can write it like this. All right, now I would always suggest that if you can see that a ratio can be simplified, you really want to do that first. It makes it a lot simpler. Okay, so if I look at 4 and 16, I know that both of these can be simplified. And if I have 1 times 4 is 4 and 4 times 4 is 16, so 1/40th is what I have in my simplest form. So if I can just set up that ratio in the simplest form, all I need to do is 1/40 is equal to 6/100. whatever this number is going to be. And then I look at this and I know that 1 times 6 gives me 6. And whatever I do to the numerator, I'm going to do the same thing to the denominator. So times 6. All right. And so 40 times 6, it's going to give me 240 as my answer. So this is one way to do it. Okay. We can also do cross products and all that I have taught in the classroom already. But just wanted to show you the equivalent ratio method. So, and then of course your double number line, which I have created here. So whatever method you use, the cat's heart beats to 240 more times in 6 minutes than the dog's heart. All right. So let's go ahead and solve another problem with double number lines. Okay. So the question states that a bulk food store sells a 12-pound bag of Red Delicious apples for $18. Okay, 12-pound bag for $18. Okay, and at this rate, what is the price of a 15-pound bag? So 15-pound bag is equal to how much? We don't know what this cost is. All right, so we can use a double number line, but I'll show you equivalent ratios also in a minute. So you can use a double number line. We're going to draw a double number line to represent the price of a 12-pound bag. And we are going to mark equal increments on the bottom number line, okay? So we have price in dollars. Okay, price in dollars, that is the top number line. And then we have pounds. Just extend this, and this is my pounds, which is the bottom. Okay, bottom number line is pounds. And then of course this is 0 here and 0 here. Okay, so since we have, we're talking about the 12-pound bag over here, we are going to make equal increments. So let's do 3, 6, 9, 12. Let's do this. 3, 6, 9, 12, 15. Okay, I've just created this because ultimately we'll be going to 15 pounds. All right, and we mark the bottom. And then we know that the 12-pound bag costs how much? $18. Okay, so all right, so now what we're going to do is I have marked this and I'm going to use scaling to find an equivalent ratio. Okay, so if I look at this, I know that I have 12 for 18, and so I'm going to scale back to find the price for a 3-pound bag. But look, divided by 12 divided by what? 12 divided by 4, okay, is going to give me 3. So same thing, 18 I'm going to divide by 4, and I'm going to end up with 4 and 5/10 over here. 12 divided by 2 gives me what? It gives me 6. Okay, and then I'm going to do the same thing over on the top. I'm going to divide 18 by 2, and I'm going to get 9. All right, and so then I can scale forward. I can see it's going up 4.5 increments over here. So the next one is going to be 13 and 5/10. All right, and then I'm going to just scale forward because 4 and 5/10 times, because 3 times 5 gives me 15, right? So 4.5 times 5 is going to give me 22 and 5/10. Or since we're talking about price, it'll be $22.50. Okay, now At this rate, the price of a 15-pound bag of apples is $22.50. Now we can also do this by solving an equation. We can write and solve an equivalent rate, and let's say P represents the price of the 15-pound bag. So we know that we have 12 pounds for, and this is pounds, for $18. So 15 pounds will be how much? Okay, so I'm just going to write, this is what we need to know. So we can just put any variable. I'm just showing you with a question mark so that you understand what I'm looking for. Okay, so I'm just going to substitute the question mark with P because we are trying to find the price. All right. Now, once again, I can do it this way. I can do cross products. I can do a whole lot of stuff, but I can also simplify the 12 and 18, right? So if I take 12 and I take 18, what are these divisible by? Both of them. Okay, I know that divisibility rules. They are divisible by 2. They are divisible by 3. So that is why they are divisible by 6. Okay, and so 12 divided by 6 is 2. 18 divided by 6 gives me 3. All right, so for 2 pounds for $3, okay, for $3. And so what I can do over here, I can also do the unit rate if I had done it that way, but still, so 15 pounds is going to be how many dollars? Okay, so I know that what is half of 15? It is 7.5. So 2 times 7 and 5/10 gives me 15. And I'll have to do the same thing to the denominator, times 7 and 5/10. And I get the same answer. Here we go. So 3 times 5, 15, 1. 3 times 7, 21, 22. And 1 digit, so look, same thing. All right, and we get $22.50. So this is one way to do it. I could have also done the unit cost. There's so many different ways. I could have also done the unit cost, and I could have done dividing 18 by 12 pounds, which is the quantity. All right, and so when I divide, first and foremost, what do I get? I get 2 here, I get 3 here. Okay, and so ultimately, what is my unit price? It is going to be $1.50 for 1 pound. Okay, so for 1 pound, if it's that much, how much if I have 15 pounds? Okay, so if I have 15 pounds, what am I going to do? I am going to do 1 times 15. Whatever I do to the denominator, I do the same thing to the numerator, and I get $22.50. We can do cross products. We can do all the different methods that I have taught you, but you will still end up with exactly the same answer. And that concludes our module 2. Have a great day.